Alright, so the last proper integration method that we're going to be looking at is integration by parts. Now this method is used when we have two functions again multiplied by each other, and when one of them will reduce to a number when we differentiate it. So we have the equation here that I've written out for us, and when we are dealt with integration by parts, we have to set one of them as u and then one of them as dv by dx. So let's look at an example. Let's say we had asked to integrate x times cos x. Right, so they're both functions, and we can't really use any other rule that we've learned before, so we can use integration by parts. So as we said before, I set one as u and then one as dv by dx. Right, so now it's just a matter of choosing which one's going to be our x and which one's going to be our dv by dx. So the general rule is you choose the one which would, when we differentiate, will eventually become a number. So if I was to choose u as cos x, if I differentiate it, then I get minus sin x. If I keep differentiating again, we get minus cos x. If I differentiate again, we get sin x, and so on and so on. And it will keep rotating, right? Keep looping. It will never reduce to 1. So whereas if I set u as equal to cos x, if I differentiate that, I get 1 straight away, right? So it reduces to an integer or a number. So that's what we're going to set as our u. That's the general rule, okay? So u is going to be our x, and therefore dv by dx is going to be our cos x. Right, so now to get du by dx, we just differentiate x, which is 1. To get v, we have to integrate our cos x, so that's going to give us a sin x. And now it's just a matter of following the formula. So it's going to be uv, so uv together first, so it's going to give us x sin x, and it's a minus, it's always going to be a minus, the integral of du by dx times by v, so these two multiply together. So we never actually use the dv by dx term, we just used it for initially to set it up, and then we don't use it again. So it's going to be integrating sin x dx. And now it's just x sin x, integrating sin x will give us negative cos x, negative negative is positive, so positive cos x plus c, as shown before. So as long as you choose the right u and dv by dx, then it's just simply plugging into the equation. Let's look at another example. Let's say we have x squared e to the 2x dx. So we know that we have to use integration by parts, so therefore u has to be something, and then dv by dx has to be something else as well. Looking at this, we have to think which one will eventually reduce to a number. Well, e to 2x, if we differentiate, will be 2e to 2x, and then differentiate again, will be 4e to 2x, and so on and so on. Whereas x squared, if I differentiate once, I get 2x. If I differentiate again, I get 2, so it becomes a number. So that's what our u is going to be, x squared. dv by dx is therefore e to 2x, and then we just differentiate this to get du by dx, which is 2x, and v is equal to, integrating it will give us half e to the 2x. Looking at the formula, remember the first thing was u times v, so it's going to be x squared times e to 2x over 2 minus the integral of these two here, right? So it's going to give us x e to 2x dx. As you notice, there's still two variables, so this means we have to do integration by parts again. So once again, we're looking at just these two now. We have to set u equal to something, and in this case u is x, dv by dx will therefore equal to e to the 2x, and then du by dx will equal to 1, v will equal to half e to the 2x again. So therefore, if I was to finally write it out, bringing this term down here, we'll get x squared e to 2x over 2 minus, and now if I do the integration by parts again, I like to put a bracket around just to not get confused with the signs. So it's going to be inside the bracket, we're going to have u times v, so x e to the 2x over 2 minus the integral of these two multiplied together, so half e to the 2x like this, close bracket. So we just need to finally integrate the last part, so we're going to get x squared e to the 2x over 2. This is now negative x e to the 2x over 2. And integrating this, we'll get 1 over 4 e to the 2x. But remember, it's negative, negative, so that's actually going to be positive plus c like this. So you might have to do it 2 times, 3 times. They won't even ask you to do more than 3 times in the exam question paper. But as long as you set the right u and the right dv by dx, then you always will be able to just follow the formula, be able to integrate in most questions. Right, there are some special cases which where we're to be aware of, and those special cases are when we dealt with a ln x. So if I have maybe x times ln x, in this case, we have to integrate it by parts again, but remember we had to set a u and dv by dx. Well, in this case, most cases, because we've looked at the x will, if we differentiate, become 1, right? So normally our u would be x. But whenever we have a function, two functions together, and we're integrating it, if we have to use integration by parts, then u is always ln x. Okay, that's a very important thing to remember. If there's ever an ln x in the question and you have to use integration by parts, you always have to set u is ln x, no matter what the other function is. Okay, it's very, very important. In which case, dv by dx is now x, and du by dx is now 1 over x, and v is just x squared over 2. The reason why we set u as ln x is because we can't integrate ln x, right? That's not possible. So we have to set u as ln x because we can actually differentiate but not integrate. But once we've done that, then we do u times v. So it's going to be x squared over 2 ln x minus v times du by dx. So integrating x squared over 2 multiplied by 1 over x dx, which will give us x squared over 2 ln x minus x, this is x squared over 4 plus c. Okay. Right, what happens if I was to now integrate, or asked to integrate ln x on its own? So as I said before, we can't actually integrate ln x on its own, but this is how you would go about doing it. So what we can do now is still going to be integration by parts. So we still have to set u as something and dv by dx as something else. Remember, if it's ln x, u automatically becomes ln x, but we need to say what's dv by dx going to be. Well, you can actually think of this as if I was to rewrite it as 1 times ln x, right? It's the same thing, right? Which means dv by dx I can set as 1. So du by dx will just be equal to 1 over x, and v will just equal to x. So now this will be uv, so x times ln x, minus the integral of these two together, which will cancel out to 1 dx. So we're going to get x ln x minus x plus c. So this is actually how you integrate, or what you get when you integrate ln x. But even if you know this, when using integration by parts, u always has to be ln x. Okay, so don't forget about that. Okay, so let's look at one final tricky question. So I want to integrate e to the 2x sine x. So this is going to be two functions multiplied together, so we're going to use integration by parts. So we're going to set our u equal to something, and our dv by dx equal to something. Remember, our u is normally the function which will reduce to a number when we differentiate. However, if I keep integrating e, I'm going to have an e term consistently. If I differentiate sine, I'm going to get sine, cos, sine, cos, sine, cos. So neither of these will reduce to a number. So in this case, it doesn't matter which one you set as u. So I'm going to set as e to 2x as u, and dv by dx as sine x. Meaning du by dx will be 2e to the 2x, and v will be equal to negative cos x. So this is going to be equal to u times v, which is give us negative e to the 2x cos x, minus the integral of these two, v times du by dx, so 2e to the 2x cos x. There's a negative sign here, so this is now going to be positive. Okay, negative, negative, positive, dx. As you can see, there's still two functions, so we're going to have to use integration by parts again. So u I'm going to set as 2e to the 2x, dv by dx as cos x. So du by dx will give me 4e to the 2x, and v will give me sine x. So this is now equal to, bringing this term down first, we have negative e to 2x cos x, plus, I'm going to use a bracket, so uv, these two here, 2e to 2x sine x, minus the integral of these two multiplied together, so 4e to 2x sine x dx, close bracket. What you should realize is, well, there's still actually two functions there. It's not reduced to a single function. But if I go all the way back up to my initial question, we were asked to integrate this term here, right? e2x times sine x. Now, if I label this I, what you can see below is this is actually the same part, right? It's just 4i. So rather than writing like this, I can write it as minus 4i, like so. And because this is all trying to find that I in the beginning, right? So like here, we can now say that I is equal to minus e to 2x cos x plus 2 e to the 2x sine x minus 4i, which means I can bring it to the left-hand side. So I get 5i is equal to this. And then if I divide everything by 5, then I'll be just left with the I. So I'll have 1 over 5 minus e to the 2x cos x plus 2 e to the 2x sine x plus c. So this will be my final answer. This is actually an example of integration by loop. So we're using integration by parts, but it basically keeps looping. What we're trying to find is a form of this original I or some multiple of this I, and that way we can stop the loop and we can actually find the actual integral. So this is like a tricky question which they could give you, but in general sense, if you're asked to do integration by parts, just make sure you choose the right u value and you choose the right dv by dx. And if you use the formula, then you could probably answer, or you will be able to answer most questions.